Namaste everyone, this is Srikanth. Welcome to my channel CADiMate, where we are giving life to the boring subjects using CAD technologies. So we will be solving a problem today, which came for the OU students in May-June 2018. So the subject is about the epicyclic gear trains, and this is what the problem is. So we need to solve this problem. You can see here that it says the annulus A is rotating at 300 RPM about the axis fixed, and the wheel S, which has 80 teeth, the 3-armed spider is given at 180 RPM. Okay, so 3-armed driver is rotating at 180 RPM. So we need to find the number of teeth required on the wheel P. Wheel P. Okay, so P is the planet here. Fine. So we need to find the number of teeth on the planet P. So in order to solve this, first we need to build a table, and the table actually starts with the arm and then takes up the central gear, that is the sun, let us say, and this is yes, and then it will go on to connect. It will go on to take the gear which is connected to yes. In this case, it is P, which is the planet. Okay, so P is the gear which we have to take next, and the gear P, you can see it is connected to the annulus A. So annulus A comes last. So this is the order in which we have to build the table. So arm A, we will just call it its arm, and the speed of arm, you can just write it as n arm. The speed of the sun, we'll write it as ns. The speed of P, the planet, is np. The speed of annulus is na. So now, in the first step, we have to assume that the arm is stationary. Fine. So this 3-axis arm that you see here, we have to assume that it is stationary, and the sun is undergoing one complete rotation. So with respect to this input, we have to find how many rotations the planet and annulus are going to perform. So to do that, we'll have to take the ratio. Fine. So np by ns will be equal to minus ts by tp. Fine. So you might be knowing why we are taking this minus, because the two gears S and P are engaging outside of each other, and the rotations are going to be opposite to each other. Now we are assuming that the NS is undergoing just one rotation, so in that case the denominator becomes 1, and NP will just be equal to minus TS by TP, where TS is the number of teeth on the sun gear and TP is the number of gear on the planet. Next, we have to go on to find how many rotations the annulus is going to rotate. For that, we'll have to again go with these two gears. P and A are getting engaged. So NA by NP will be equal to TP by TA. Now in this case, you must be observing that we are not taking a negative sign, because P and A are gearing internally, and their rotation direction is going to remain the same. So there's not going to be any change in that. So taking this and moving ahead, we can find the speed of NA as NP times TP by TA. Now NP, we know the number of rotations that it is undergoing, that's equal to this. So minus TS by TP is the number of rotations that it is undergoing, and the remaining is going to appear as it is. So TP by TA will appear as it is. These two terms are going to cancel, and we'll just be left with minus TS by TA. So that's how many rotations the annular wheel is going to make. So that will just depend on the number of teeth on the sun gear and the annular wheel. Now that we have got the number of rotations which each of the gears are undergoing when the number of rotations of the sun is 1, the next step, what you have to do is we have to multiply x throughout. So instead of just one rotation, we'll be taking x rotations for the sun gear, and then we'll have to find the number of rotations which all the other gears are undergoing. So that's just going to be multiplication of x with whatever term we have got. So this is going to be minus x ts by tp, and this one here will be minus x into ts by ta. So these are the number of rotations which each gear is undergoing when there are x rotations on the sun gear. In the next step, we'll be rotating the arm completely. Complete arm itself, we are going to rotate by y rotations. So when that happens, each of these gears are going to rotate by y degrees. So y 0 plus y is going to be y, x plus y will remain as it is. Here we will get y added, so minus, I'll just write it later like this, and this term here becomes y minus x times ts by ta. So these are the equations, which are giving us the speeds of all the gears that we have here. Fine. So now using this data and the input that is provided here, we should be able to do the calculations and find whatever is needed. So let's note down the given data over here. Fine. So the given data is, you can see that the annulus A is rotating 300 RPM. So since no direction has been given, we'll just take it as a positive value. And it's rotating about the axis of the fixed wheel S. So when it says the wheel is fixed, that means the speed of S is 0. Fine. So this is something which we have to read between the lines. If you forget about this, then the whole problem is going to be completely mess. So next, continue. The wheel S has 80 teeth, so TS is going to be 80. And then you can see the 3-armed spider. So this is the 3-armed spider that he's talking about. That is getting driven at 180 RPMs. Once again, the direction has not been given. We'll just take as the positive value. So that's it. That is the given thing. And then we have to find something. So what have we got to find? So we have to determine the number of teeth required on the wheel P. So we have to find the number of teeth required in P. So this is what we have to find. Now you can see we have already prepared the table, and with the table ready and the given and required data having noted down clearly, it's not going to be much difficult for us to solve this problem. So let us go ahead and try to solve it. So first of all, NA is equal to 300. So NA, the formula, you can see the NA formula goes like this. So y minus x times TS by TA. This is the formula for the speed of annulus A, and that speed has been given to us as 300. The next equation we have to use is the speed of arm. So speed of arm, the formula is simple, very, very simple. It's just y. So y value also we know that is 180. And the speed of S, the sun, that is x plus y. So x plus y is equal to 0. Okay, so now all we have to do is solve, substitute all the given data into these equations and solve whatever is required. That is, in this case, TP. So first of all, let us solve this equation. It seems to be very, very easy, and with y value already given, we can substitute and we can find the value of x, and that's going to be minus y, so it's going to be minus 100. Now let us substitute the equation of y as well as the value of x into this particular equation along with the value of ts that is known here, and we can find the value of ta with all those. So here y value is 180, so to substitute, minus x value is minus 180, so minus of minus, that's going to be cancelling. Then ts by ta, ts value we know it is 80 and ta value is unknown, equal to 300. That's what is there on the other side. So now it's actually going to be, there is one more going, bracket has to be present over here. Fine. So opening the brackets, sending all the terms to the other side, ta is the only term which we have to find. So 180 times 80 divided by ta, minus and minus is going to cancel out, and this 180 when it goes to the other side is going to become minus 180, and now cross multiplying we will get the value of ta, that is 180 into 80 the numerator, and this value goes into denominator. So 300 minus 180 we know it is 120, so I'll just put it directly over there. Then cancelling all these values, 6 2s are 6 3s are, and 2 is 4, 3 4s are 12, so 120. So TA is going to be 120. That means the number of teeth on the annulus is 120. But we don't need TA, we need TP to be found. So next, what is the next step? So now we need to use the knowledge of module here. Fine. So the distance from this point to this point is half the diameter of annulus. So diameter of A by 2. And this can also be found in terms of the diameters of P and the diameter of S. Fine. So you can see the whole diameter of P is coming here. So diameter of P, whole of it has to come here. And below here you can see this is half the diameter of S. So plus half the diameter of S. So this is the equation which is relating the diameters of all the gears that we see in this epicyclic gear train. Now we need to convert this relation between the diameters into the relation between the number of teeths. Now, how are we going to do? We are going to do by using something called module. Fine. So for those who don't know, module is the fixed value of a gear, and the module of two meshing gears which are meshing with each other, they have to be same. Unless modules of two gears which are meshing with each other, unless that modules are equal, the gears are not no, they will not be able to mesh properly with each other. What's the definition of this module? Module is equal to diameter by number of teeth. So if you have to convert the diameters into number of teeth, so diameter is going to be module into the number of teeth. So this is the equation we'll be using. So we have to apply for all the three gears the same equation. So module into number of teeth on annulus by 2 is equal to module into number of teeth on planet. This is complete, there's no by, plus ds will convert into module of the yes gear into number of teeth on yes gear by 2. So now this module that we have here can be taken common. Fine. So this can be taken common. It is going outside here, outside the bracket, and these two are going to cancel out. So we are now getting a relation completely between the number of teeth. So TA by 2 is equal to TP plus TS by 2. Now we already know the number of teeth on yes. This is 80. So 80 by 2 will come here. And we have found the number of teeth on A gear, that is 120. So 120 by 2 will come here. And TP is the number of teeth on the gear P. So that you can see is the only number of teeth that is unknown. So that we can easily find. Just simplify this. This is going to be 60. This is going to be 40. And number of teeth on planet is going to be 60 minus 40, and that's 20. So this here is our answer. So hope you have understood this problem perfectly, and those who are attempting the exams, if this similar question appears in the exams, you'll be perfectly able to answer this. If you have any questions or any other kinds of questions that you want me to solve in my channel, please answer me in the comment section below, and I'll definitely try to make a video on that so that it will be beneficial to all the students. Thank you.